All right, so in class we looked at notes on page 61 and 62. So I wanted to make a video just to go over that in case you were absent. So this is the new workbook, page 61. So we're going to talk about how to actually make the graph of our exponentials. We talked about the table last class, but this week we're going to talk about how transformations can affect our graph and other pieces of how we can find points that lie on our graph. Our exponentials come in the form of a times b to the x power. So there's always a horizontal asymptote, there's always a y-intercept, and then we'll find those two plus a little bit more information to be able to graph. So one thing to note is our exponential growth is when we're raising a whole number or a number greater than 1 to the x power. So 2 to the x, 3 to the x. It could even be a decimal as long as it's greater than 1. It could be a fraction as long as the fraction's greater than 1. But anything greater than 1 is going to give us exponential growth, which is going to be our graph growing from left to right. And then on the other side, if it's a fraction or a decimal less than 1, between 0 and 1, it's going to be exponential decay. So it's going to start high and work its way down. All our parent functions for an exponential have a horizontal asymptote at y equals 0 for both growth and decay. So that'll be kind of the first thing we focus on when we graph. So if we look at number 1, it says, has the graph transformed up or down? So remember, our transformations up or down would be if we're adding or subtracting anything outside of x. So here we are not. So that means that our horizontal asymptote would be at y equals 0. So we would have a horizontal asymptote at y equals 0 still. So then there's going to be kind of two things that we focus on to graph from there. And it's going to be finding 2 points. One of them is going to be our y-intercept. So that's when we make x equals 0. So here, if I want to make x 0, I have 2 times 3 to the 0 power. Anything to the 0 power is 1, so 3 to the 0 is 1, so then 2 times 1 is 2. So when I made x 0, I got that y was 2, so I would graph 0, 2. And then we want to find another point. So an exponent of 0 is really easy to find, an exponent of 1 is really easy to find. So making that exponent 1, I can make x 1. So then 3 to the first is just 3. So then 2 times 3 is 6. So when I made x1, I got a y value of 6. So I can graph that as well. 1, 6. So we're always going to focus on finding 2 points on our graph. And then that will allow us to see our sketch. So as you can see, and you should know by looking at this picture, since I'm doing 3 to the x power, that this is exponential growth. So then my graph should start down and then will work its way up through those 2 points. So we're going to focus a lot on finding 2 points and then being able to sketch the graph based off of the horizontal asymptote and those 2 points. So then from our sketch, we should be able to determine our domain and range. We talked about this in class. Our domain, there's no x value that we can't use. We can raise this number to any power. So our domain would be negative infinity to infinity, right? This graph is going to go to the left forever and to the right forever. So it's going to use all x values. Our range, we're not going to be using any of these negative y values. Because of that horizontal asymptote at 0, my graph will not pass 0. So we're going to use a parentheses because 0 is not included, but every number after 0 is. So even 0.00001. So we want every number after 0 to infinity as our range. So if we look, and if we were going to talk about the transformations of this one, this 2 in the front we would call a stretch by 2, just so we're listing out our transformations. So then if we look at number 2, first has the graph been transformed up or down? So this plus 3 means that yes, my graph went up 3. So that really affects, the main thing that affects is our horizontal asymptote. So if our graph moved up 3, that means that our horizontal asymptote moved up 3. So instead of being at 0, it's now at y equals 3. So that up and down transformation really affects our horizontal asymptote. So now that we know where our horizontal asymptote is, again, our goal is to find 2 points that we can graph. The first one always being the y-intercept, so when x equals 0. So if I have 2 to the 0 plus 3, right, we're making x 0. Anything to the 0 power is 1, and 1 plus 3 would give me 4. So my y-intercept is at 0, 4. And then we always want to find another point. So having the exponent be 0 or 1 are always easy to find. So if I make this 1, I can find 2 to the first very easily. So instead of having my x value, I replace it with 1. 2 to the first is 2, plus 3 would give me 5. So then I know that this point is at when I made x1, y was 5. So I can graph 1, 5. So then my graph, knowing that it's also a whole number greater than 1, we know this is exponential growth, and we can tell because my points are moving upward from left to right. So we can sketch our graph from those 2 points. Again, we know it's exponential growth. We know it's growth because we had 2 to the x power. So again, our domain is not going to change for any of these exponentials. There is no x value that's off limits, so it's always negative infinity to infinity. Our range did change here because our horizontal asymptote moved up to 3. So now my graph is not going to cross the y value 3. So since my horizontal asymptote is at 3, my range starts at the asymptote and then goes up forever and ever and ever. So it's from 3 to infinity. All right, so if we look at those problems on the back, so first thing we want to talk about is that horizontal asymptote. Did it get moved up or down? So with this -2, that transformation on this graph would be down 2. So then that means, yes, my horizontal asymptote moved down 2. So normally it's at y equals 0. Now it's going to be at y equals -2. So I can draw that in. Right, moving the graph down 2 moves my horizontal asymptote down 2. So from 0 to 2. Again, so when we want to find our 2 points, we're going to find 2 points on this graph. One of them is always going to be when we make x equals 0, and then the other point is up to us, and we'll kind of look at what that is later, what that means later, but most of the time we want to work when our exponent is 0 and our exponent is 1. So here, when our exponent was 0, we have 1/2 to the 0 power minus 2. Anything to the 0 power is 1, and 1 minus 2 would give me -1. So when x was 0, y was -1. So I can graph 0, -1. And then I'm going to plug in the value 1 for x. So if I do that, I would have 1/2 to the first power minus 2. So then 1/2 to the first power is just is just 1/2. And then 1/2 minus 2 would be -1.5. Or if you wrote this as a fraction, you would have 4 over 2. So then you could have this as -3 over 2. If you think about you had 2 whole pizzas and a half went missing, you would have 1.5 left. So that means that this point, when x was 1, y is either of these values. You could also, if you wanted to write it as a decimal, -1.5. I prefer either the mixed number or the improper fraction, -3 over 2. So we know at 1, mine was -3 over 2, which is a little more than 1, but less than 2. So we're looking at about right there. And if we put this in the wrong spot, we would know that because the exponent is to a fraction, this should be exponential decay. So from this point, I should be going down. So I should have seen this number lower than the initial point that I found. Like I said, all of my domains are -infinity to infinity. And then because my horizontal asymptote is at y equals -2, my graph is not going to get any lower than -2, but will go up forever to infinity. And even though it looks like infinity on the left and -2 on the right, remember we always write our domain and range from least to greatest, so that -2 should come first. It is still going, the lowest y value is -2 to infinity. All right, so if we look at another one together. So first we look at it, if our horizontal asymptote has been moved. So did our graph move up or down? We're not adding or subtracting anything here, so that would be a no. The transformations that take place here would be a stretch by 6, right? That's 6 in the front is a stretch. And then a +1 with X would mean that this graph moved left 1. So it's good to recognize what our transformations are. The up and down are really the only ones that kind of help us graph, but it's still important to be able to state our transformations. So since it's no, our horizontal asymptote is going to stay at 0. So now, again, I always want to find 2 points on the graph. One important one is always making x equals 0, because we want to find the y-intercept. So when I do that, I would do 6 times 1/3 to the 0 plus 1. So now this one's different because my exponent, I'm actually doing 0 plus 1. So that is 1. So then I have 6 times 1/3, which would be the same thing as 6/3, which would give me 2. So when x was 0, y is 2. Yeah, so with that adding up at this exponent, that actually changes that value up here. So you want to be careful when you're simplifying, that you're simplifying the right pieces or simplifying in the right order. I'd want to add these exponents together before I simplified what the exponent would give me. So at this point, I've been telling you to plug in 0 and plug in 1. You will always plug in x equals 0. That is always, because we always want to know the y-intercept. But I'm not necessarily tied to always plugging in x equals 1. I like when my exponent is 0 and 1. So here I got the exponent of 1. So now I want the exponent of 0 up here. So I want to figure out what x value would give me an exponent of 0, because I can find anything to the 0 power is easy to find. So I'm actually going to plug in -1. And the reason being, when I do that, I'll have -1 plus 1, which means I'll have 1/3 to the 0 power. And again, I really like having my exponent to the 0 power and to the first power. So this initial one, when I made x 0, I was working with the first power. So now I want to make it as the 0 power, because anything to the 0 power is 1, and then 6 times 1 is 6. So in this case, I actually used the x value -1 and got +6. So -1, +6 would give me my second point. I could have plugged in 1, but then I would have had to the second power, and 1/3 to the second power is 1/9, and I just feel like that's a little trickier to work with. So I actually want to focus on getting something to the first power and to the 0 power by making x whatever value it needs to be to get a 0 and a 1 here. And then that just makes my graphing a little bit easier because I'm working more with whole numbers. And then again, we should see my graph is going down because I'm raising a fraction to the exponent. This is exponential decay. My domain is always -infinity to infinity. And then here, my range, since my horizontal asymptote was at 0, my range is 0 to infinity. So like I've said in this video, if my b value is greater than 1, so that means like 3 to the x power, you could even do like 5/4 to the x power, because technically that fraction is greater than 1. It's exponential growth. Even if you had here, if your a value was a fraction, so if I had 1/2 to the 5 to the x, this is still exponential growth because it's the number being raised to the x power. That is the whole number, or the number greater than 0. And then exponential decay is when these numbers are fractions. Fractions that are less than 1. So again, this is greater than 1, that's why it's exponential growth, but these fractions all have to be, or decimals, all have to be less than 1. So in class, we did a lot more practice graphing the exponential. So I would strongly suggest taking a look at your homework, because there is a quiz in class next week. So your homework is page 63 and 64. So I would just make sure that you feel comfortable graphing going into class on Monday.